Hello, Algebra 1 students, and welcome back to your Semester 2 final review. Problem 27 comes from Lesson 7.6. It's where we first learned about the average rate of change of parabolas. This question wants us to find the average rate of change of f of x, where f of x is the graph over here, over the interval 0 less than or equal to x less than or equal to 6. So a few things to break down here. First, what is the average rate of change? Well, we don't, at least until calculus, discuss the rate of change or the slope or the steepness of our parabolas at specific points because the steepness changes everywhere, right? If you look at this steepness right here and compare it to this steepness up here, clearly this is more steep than this one, right? Now, the problem is we don't know how to find the exact steepness at these curvy graphs. For lines, it's very easy. If you just had a line, it's the same steepness everywhere. You just count your rise, your run, and it tells you how steep the line is. Again, because every point on here has a slightly different steepness, we don't talk about the slope at a single point. Instead, we talk about the average slope or the average steepness. When they ask you for the average rate of change, the average slope, they're going to give you two x values. So here they give us an x of 0 and an x of 6. And in fact, I think it's a good habit to get into to write those out. We have an x of 0 and we have an x of 6. If we want to find the average rate of change, we need to actually determine which points we're finding the average rate of change between. So here is an x of 6. Here is an x of 1. We're not just looking between those two, though, because we're curious about the average rate of change of f of x. So we need points that are actually on this graph. Now, for example, if you look at this point down here, this is the point negative 6, awkward, negative 6, comma, negative 12. This point has an x value of negative 6. In fact, every point up here, for example, this one is negative 6, negative 4, every point on this vertical line has an x value of negative 6. But the only one I would be interested in is the one that's actually on f of x. And so we're going to do the same thing with 0 and 6. Let's start with 6. An x value of 6, well, every point that I'm putting right here has an x value of 6. But what's the only point I care about? Well, that is the point actually on the function right here. And this is the point 6, comma, negative 12. The second point is when x is 0, and there are all sorts of different points that have an x of 0, but the only one that I care about is the one that's on the function, the point 0, comma, in this case, 0. So now we need to go through and determine what is the average steepness between those 2 points. And there are 2 ways to do this. The easiest way is to count your rise over run. So I'm just going to count my rise, and it looks like instead of rising up, I rise down or I fall down 12, and then I run over 6. So my average rate of change, ROC, is going to be rise over run. And if you reduce this, negative 12 divided by 6 is negative 2. So I think we're ending up with D. The other option is if you forget how to do that, you can always take these 2 points and you can use our slope formula, right? Our slope formula is that y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And if we wanted to label those points, this is the first x that I come to, so I'll call it x1. That's the first y. Second x, second y. And so we're going to substitute those into our formula. Y sub 2 is negative 12. Y sub 1 is 0, divided by 6 minus 0. And as you go through and simplify this, we end up with negative 12 over 6, which is, of course, our same average rate of change. So thanks for tuning in here. As always, if you need more explanation or more practice problems, check out Lesson 7.6 and keep being successful on that practice final.